Here's the shortest possible explanation for quadratic inequalities. Unit 3, Lesson 2. You'll have a quadratic equation, but it won't be an equation, it will be an inequality, which means instead of the equal sign, you'll have either greater than or less than. So you would graph with a dashed line, or less than or equal, greater than or equal, so you'd use a solid boundary. Anytime you have greater than or equal, that means your solutions are greater than the vertex. Anytime you have less than or equal, that means your solutions are less than the vertex. Also, you need to label what quadrants contain solutions. Once you graph your curve using the appropriate boundary type and shade either greater than the vertex or less than the vertex. To determine how to number, so that you can remember how to number your quadrants, you can draw a C around the origin. Think counting. So C, 1, 2, 3, 4. And we use Roman numerals to label the quadrants. That's the big, scary deal with quadratic inequalities. That's basically it. So if I were perhaps graphing, let's see, y is greater than 2x squared minus 5. Well, I can type that into any kind of graphing software that I have. Y greater than 2x squared minus 5. And I have a dashed line boundary. And my solutions are greater than the vertex. The vertex is right here at 0, -5. So then what I need for you to do on your assignment is to sketch an accurate graph. If this is 0, -5. And then let's get a couple of points that are good points here. -1, -3 is really close. Spot like that. -1.5, 0. Let's try this. -2, +3. About here. Okay, so I've got a curve and it looks like this, and my solutions are everything inside this because they're everything above the vertex. So I have solutions shaded in quadrants 1, 2, 3, and 4. That's how I would list my solutions. My vertex is at 0, -5. And my solutions are shaded inside the parabola. And I have a dashed boundary. That's really all we're looking for. Let's do another example. What if y is less than or equal to -x plus 1 squared plus 3? I'll type that in here. here I have a curve with the vertex at -1, 3. And it opens upwards. And I have a point at 0, 4 and a point at -2, 4. And my boundary is a solid curve. And my solutions are everything less than or equal to the vertex, which is everything that's outside the parabola, which in this case is also in quadrants 1, 2, 3, and 4. My vertex is at -1, 3. I shaded outside the parabola. I used a solid boundary. And my solutions are in quadrants 1, 2, 3, and 4. By the way, your solutions are not always in quadrants 1, 2, 3, and 4. Look what would happen if I just changed this symbol here. What if I did y greater than or equal to the same curve? I just changed the direction that I shade. So all I'm changing here is where my solutions are. So now I have the same curve with a vertex at -1, 3 and opening upward with a solid line boundary, the same. But if I change to greater than, then I would shade above. Vertex, which is inside the parabola. My vertex is still at -1, 3, and I'm still using a solid line boundary. But now my solutions are in quadrants 1 and 2, not in 1, 2, 3, and 4. So with those 3 examples, give lesson 2 a shot.